G'day. I was asked to have a look at this the other day. The bore of this needs to come out slightly, and the person who owns it, their mill and the lathe aren't quite big enough to put this in. Mine is, but I thought I'd talk a little bit about a couple of the issues this presents because it is interesting and could help you out of a jam at some stage. This is one of the wheels out of a bandsaw, and the problem here is the bearing has chewed up the bore here a little bit, and so the bearing no longer fits neatly. It rattles around a little bit. A couple of ways of looking at this or fixing this problem. One is you could bore this out, possibly weld a plug in of some sort, or just push fit, and then rebore that to suit the bearing. Another possibility, and this is the one that's been elected to be pursued, is to put a slightly bigger bearing in there. And so I need to bore this out to match a bigger bearing. Now, this is 14 inches in diameter, 360 millimeters. So it won't fit on my lathe. My lathe's got a maximum swing of 12 inches, and if you've got a Hercus lathe or something like that, you're even worse off. So lathe is out. Mill is a possibility. When people think about boring in a mill, particularly a vertical mill like this, they think about putting it there and boring in the XY plane. Now, I've got enough throat depth here that I can do this. That's not a big problem. However, if you've got a small mill, you may not. And so there are a couple of ways around that. Well, there are a couple of possibilities, shall we say, around that. One is if you've got a tilting head, you could tilt the head around 90 degrees, make up a fixture, and then bore it that way. And what that might do is that might give you enough room there to clear the column. So that's something worth considering. If you've got a mill which converts to a horizontal spindle, you could do the same thing there. You could make up a fixture, secure the part like that, and then bore with the spindle coming out of the column. So a lot of people, when they think boring, particularly on a mill, think boring in an XY plane, but there's also the YZ and the XZ plane. So there are a couple of possibilities to consider. Another possibility, believe it or not, is a drill press. This one will just fit. So if this is one of those, I've got to fix this otherwise the world will end sort of problems, then there's a possibility there. Normally, milling in a drill press is not recommended, simply because the spindle is held by a taper, and tapers don't like sideways force like that. They'll come out, and then you'll have a big mess. The other thing is that a chuck like this may slip, and so you need a specialised chuck to hold a milling cutter or a boring bar. But if you had a way of, with a drawbar say, of securing a boring head in there, if you had an M3, in this case an M3 boring head, you could possibly clamp that to the table, centre it all up, and then away you go. So there is a possibility there with a drill press. It's one of those last resort sort of things, but sometimes that's what you've got to do. Once you've worked out how you're going to bore this, the other problem becomes one of centering it. What you could do is come along and probe the bore and use that to center it, and whether you use a wiggler type indicator or as I do, something like a centricator, 3D tester, optical, whatever, you can indicate off the bore. However, with a wheel like this, the bore needs to be concentric with the outside. And so if you're putting in a new bearing, a new bore here, it needs to be concentric with the outside here. There's quite a reasonable chance with something like this that it is concentric, but because that bearing is flogged out the hole, you've got a problem. And if you were doing the first solution I suggested and were going to plug that and then rebore, you wouldn't have a bore to measure from. Similarly, if you've got a casting and the casting requires a whole particular distance from a round or a surface or something like that, you haven't got that luxury of having an existing hole to work from. So how else can you do this? Well, there are some ways. This is a bit of a demonstration to show you what I'm talking about here. I've got my 3D taster up there, and I'll use that to centre. So I'm roughly around about where I think I need to be. So I just found the centre of this plate using the bore, and I've set that as the absolute coordinate on the DRO. The reason for this plate is just that it's a plate. I know it's relatively round. I'm pretty sure it's concentric because the bore and the circle holes is an important thing, and so I just wanted to use this to show. Now, obviously this is an overhanging the sides of my table, so I can come along and probe the outside. But what I'm going to do is remove or get the taster out of the way, put a clamp in here and take these clamps off the outside, and then centre it using this to show what the error there is, and then centre using another method, which you can use if something is overhanging, so you can see the difference between the methods. Here's the DRO. I've probed the outside. I've now centered the probe slap back in the middle where the incremental coordinate says it's 0, 0. And if I now change to absolute, I'm pretty close. 0.02 in Y and 0.01 in X. So, as I said, I haven't measured that, and so that could well be what it is. Okay, we'll now use the other method and see how we go with that. Here I am again ready to measure. Now this time I've put some tape across the disc here to say, or to illustrate, okay, supposing my table is only that wide, how am I going to do this? Okay, this way I can do it the same way as I did before. I can come along and I can probe that and I can probe that and everything's wonderful. Here I can't get to these bits. So what we're going to do is we're going to probe on the corners here, and keeping the X constant, we're going to pick up on the other side there, and that should still enable me to centre. This way I can still centre this way, and so I should get something which is pretty close to what I had before. Again, like the previous time, I've centered the probe over the incremental coordinate center. This time I'm a little bit better on my Y, probably took a little bit more care, but I'm still 0.05 off there, so it's not too bad. I've mounted the wheel up here and using the sort of the, for want of a better term, the rectangular method, centered it up. Just for interest's sake, I've put an indicator on the bore there, and I'm getting around about over here somewhere. I'm getting around about 1/8 thou out, and that's what's that, 0.2 of a millimetre. It doesn't worry me too much. It's a bandsaw, and 0.2 millimetre wobble I don't think is going to be too awful. If that's actually a true reading, and the inside of this bore is scored and all sorts, so you don't know whether that's because the bearing's flogged, because the indicator isn't reading properly, because it's just running over some rough spots, all that sort of thing. Anyway, I hope this is of use to people, and maybe this technique will come in handy one day for you too.